Okay, so example number 3 is very, very, very similar to example number 2, which we tackled in the last video. So what I strongly suggest you do is work this out on your own and then double check to make sure that you did it correctly. So you want to prove that these two are perpendicular bisectors. And again, perpendicular, you're going to have to look at the slopes to make sure they're opposite reciprocal. And then bisector, you're going to have to look to see that they have a common midpoint. Okay, so the first thing I'm going to do is graph CD, which is at 2, 2, and 0, 0. 2, 2 is here, 0, 0 is here. So here's C and D. I'm going to go ahead and add a line. Oops. There we go. Third time's a charm. And then I'm going to do AB, which is a 2, 0, 0, 2. Change this pen color to red. So 2, 0 is here. And 0, 2 is here. So I'm going to connect those with a line. Connect the dots. There we go. All right, so now I want to prove that those are perpendicular bisectors. First thing I do is look at CD and see what the slope is. Again, slope is rise over run. Though it says to go from C to D, you always read a line from left to right, so I know that's a positive slope. It's up 2 over 2, so 2 over 2 simplifies to 1. And if I look at from B to A, even though it says find the slope of AB, I still read a line from left to right. This one's going down, and I notice it has a slope of negative 2 over 2 or negative 1. Because these are opposite reciprocals of each other, I can say that they're perpendicular lines. Now I need to find the midpoint of CD. So I'm simply going to add my x values and divide by 2. So 2 plus 0 divided by 2. And then I'm going to look at my y values, which is the same, 2 plus 0 divided by 2. And I should notice that that comes out as 1 comma 1. Okay. And then I'm going to do the same thing for my midpoint of A to B, which is 2 plus 0 and 0 plus 2. So I see the exact same 2 plus 0 over 2, and then 2 plus 0, or 0 plus 2, it doesn't matter, divided by 2. When you add, it's commutative property, so it doesn't matter the order. So I notice that, yes, in fact, I get the same midpoint. So mathematically, I've proven it. Now, what I'd like you to do is actually practice going through all the statements, okay? And if you need to reference something, you can reference this right here. So you're going to literally write CD with these points, AB with these points that you're given. The second thing you did was you found the slope of the two lines using the slope formula. So literally, your answers here are going to be exactly the same as what we got here. But practice writing it, practice reading through it, because you never know when that's going to show up. So this is your homework for tonight. So go ahead and try it on your own and then come back if you want to and watch the video. You're also going to actually turn this in to me. It is a tied paragraph. I have to turn it into the front office for them to look at. So you're going to write a tied paragraph, and it's essentially going to be an email. And you're writing it to Alex, and you're going to explain how you did this proof in a 4 to 5 sentence paragraph. If you need more, that's fine. So you're going to use tied as your thing. So basically when I grade it, I'm going to be looking for these components. Did you A, answer the question? And then each of these is worth 20 points. So 20, 40, 60, 80. And then I'm looking, did you actually answer the question? That's where we get to 100 points. All right, so going back, it says the vertices, you want to prove whether this is an isosceles triangle. So I remember I'm going to have to go back to this example here as my model for solving this problem. So I'm going to come here, and I know I'm doing the square root. Okay, so basically I am finding the distance of AB, so I look at these two coordinates. I subtract the x's, square it, subtract the y's, and square it. So I've set this up. So 1 minus 9 is 8. 8 squared is, of course, 64. And then I've got 7 minus 3, which is 4. 4 squared is 16, so it's 64 plus 16, and then I take the square root of that. So I pull out my calculator. And really, this is not the part that's really that important. 64 plus 16 is 80. And when I take the square root of 80, I end up with about 8.9. So I can say the square root of 80. Okay. Now here I've got 9 minus 3, which is 6, and 3 minus 1, which is 2. So this is 6 squared, which is 36, plus 2 squared, which is 4. So 36 plus 4, well, that's 40. So that's not going to be congruent to the side before. It's the square root of 40. All right. So here I've got 3 minus 1. Well, that's negative 2. 2 squared is 4. And then 7 minus 1 is 6. 6 squared. So this one is 4 plus 36, which is also 40. So that's going to be a square root. And so I've noticed now that my two congruent sides are here and here. So yes, this is going to be an isosceles triangle because these two sides are congruent. So now when I come down here, I put my statement in that's given. So I'm going to say the distance of BC equals the square root of 40. And the distance of AC is also the square root of 40. And over here I would actually type in my distance formula, the square root of blah, blah, blah. You're going to write it in here, but I'm not. All right, and then number 3, after I've proven the distance, well, I don't remember what to do here. So I'm going to come back to my example problem here and check out what was it. Oh, so I say the two side lengths are congruent because equal measures equal congruent segments. So I'm going to come back and do that here. So AC equals BC, and it's equal measure, equal measure, equal goes to congruent segments. Congruent. I'll just write congruent. You get it, congruent segments. Obviously, I'm doing this from home. All right, and then statement 4 is actually my proof, and that is that ABC is an isosceles, and it's the definition of isosceles triangle. So I would say a triangle ABC is isosceles. Please remember to turn in your tied paragraph. And again, this is what the expectation is. Now that I'm saying that 3 to 4 sentences, I'm changing this. It needs to be 4 to 5 sentences, okay? So we're going to turn this in. Also, you need to be working on IXL, K2, K4, K5, and then the ones I told you for extra practice as well. All right, thanks for watching and good luck.